All right, boys and girls, we are moving on to teak number 5. All right, so this happened at the beginning of the year. Hopefully you remember this. Let me change colors. I've been using that black one this whole time. All right, so here we go. We're just going to be solving equations. Hippity-hoppity distributed property. I'm going to give you a second to do that. Remember, this 2 is going to go here. Okay, I'm going to start working too, but you keep working. 4 times x will be 4x. 4 times negative 4 will be negative 16 equals 2x. 2 times x will be 2x. 2 times negative 4 will be negative 8. Combine like terms that are on the same side. So 4x minus 16 equals 4x minus 8. I can kind of already see, look, 4x minus 16 equals the same thing as 4x minus 8. They're not even the same. Like, if you just look at it, this is minus 16, this is they're not going to equal each other. If I kept going, I would move the x's to one side and the numbers to the other. So I would subtract 4x from both sides. 4x minus 4x is 0. 4x minus 4x is 0. And you end up with negative 16 equals negative 8. That is not true. That is what we call false. So if it's not true, that means nothing would work. No number that I put in there would ever work. If nothing works, I say there's no solution. This equation has no solution to it. I can't solve it. All right, let's try the next one. Draw your line. Hippity-hoppity distributive property. Hop to it. When you get over here on this other side, you're like, okay, so Miss Dean, I'm not too sure about that side. When you have a negative, remember it is a negative 1. So you're going to hippity-hoppity with that negative 1. Keep going. All right, 3 times 2 is 6x. 3 times negative 4 is negative 12. 2x. Negative 1 times 3 will be negative 3x. Negative 1 times 5 will be negative 5. Put your like terms together that are on the same side of the equation. I'm looking over there at 2x minus 3x. I can put those together. So 6x minus 12 equals negative 1x minus 5. X is on one side, y is on, or numbers on the other. So I'm going to add 1x to both sides. 6 and 1 will give me 7x minus 12. Those cancel out, negative 5. Add 12 to both sides. Why do you add? Because that's a negative. You've got to do the opposite. Add 12 to both sides. So 7x equals 7. Divide both sides by 7. And x equals 1. All right, down to the next one. This one is an inequality, so we got to be careful in case we have any negatives that we divide or multiply by. So 24 minus 4x less than or equal to, hippity-hoppity with that negative 6. Negative 6x, positive 42. Negative times a negative will be a positive. And then I have that little negative x on the end. Remember, anytime you have more than 3 or more than 2 on one side, 2 terms, you probably have something that can put together. I have 3 terms over here, so I'm going to put my x's together. So 24 minus 4x less than or equal to negative 6 and negative 1 give me negative 7x plus 42. If you hear all that clicking over there, Isaac's next to me on another computer on a game. Definitely like click, click, click. All right, so this is my x side, this is my number side. And there goes Caleb on the Xbox. I'm going to add 7x to both sides. So 24 plus 3x less than or equal to, those cancel out, 42. I'm going to move this 24. So 3x less than or equal to, let's see, 3, 12, that'll be 18, and it'll be a positive. Divide by 3. Trying to let you catch up. I know I did that fast. X is less than or equal to 6. Now I'm going to go back and double check and make sure I didn't miss flipping my sign anywhere on here. But I don't think here when I added 7x, this was positive, making this positive. The only way I could have ended up flipping the sign is if this 3 would have been negative, and it wasn't. It was a positive. So x is bigger than 6. So I'm going to come here to 6. I'm going to circle it because that's where I'm going. It does have the equal sign, so I am going to color it in. It's all the values that are less than 6. It points to the left, so that means when I shade, I'm going to shade to the left. There it is. All right. There are 9 books stacked on the shelf. The thickness of each book is either 1 inch or 2 inch. The height of the stack of 9 books is 14 inches. Write a system of equations, and right there, big words. If I see that, that means I'm going to have 2 equations that I got to write. That can be used to determine x, the number of 1 inch thickness books in the stack, and y, the number of 2 inch thick books. How many books do I even have? Yeah, it tells me there are 9 books, so that's one of my totals. What's my other total? $14 inches. So I need to figure out what equals 9 and what equals 14. The number of books is 9. So if I add how many books I have in my hand, that should add up to 9. I have 1 inch thick books and 2 inch thick books. And if I put them together, I should have 9. So if I add my books together, I should have 9 books. Now the other one has to do with thickness. So I'm adding something to get the thickness. Well, I've got 1 inch thick books and 2 inch thick books. There's my 2 equations. I'm going to circle those so they don't get confused. There's my 2 equations. Write a systems we can, blah, blah, blah. Oh, okay, I don't have to solve it. Yay! All right, I like it. I know the systems on the test, there's a whole lot where you set them up and you don't actually have to solve them. So that is kind of nice. Okay, so here we go. We got to solve this one. Now, I am a big fan of elimination. So I'm going to do this one 2 ways. I'm going to start it with elimination, and then I'm going to let y'all finish it. I'm going to guess most of the honors kids are going to do elimination. Most of my on level, my 1st and 5th block, y'all are probably going to want to graph it. So for graphing, you need to take both of these equations and solve them for y. So we're going to take 3x plus 7y equals -5. Move the x and divide the y on both of them. Okay, so you're going to start moving the x, dividing the y. That's going to give me 7y equals -3x minus 5. Divide by 7. I wasn't going to do all of it, but I ended up doing it anyway. 3 over 7x minus 5 over 7. Now, right off the bat, when I see that, I'm going to guess that this is not going to have a nice, neat answer. I think this is going to have a yucky answer. But go ahead and try it. Those are my on levels. Keep going. All right. Those of us that are doing elimination, we're going to draw the line. And we're going to try and figure out what could we multiply by so that these cancel out. Oh, this one's yucky. Like nothing matches up, does it? I would have to multiply the top by 8 and the bottom by -3 in order to make this work. At this point, I might be thinking maybe graphing, but I'm just going to go with it. We're just totally going with it. I don't know the answer, so here we go. Let's rewrite this. 8 times 3, so we're going to have 24x plus 8 times 7, 56y. 8 times -5 is -40. This will give us -24x minus 27y equals -18. All right, so we're going to add those up. I'm going to go back over here and work this one. Add those up. Remember, this is going to cancel out. I'm going to grab my calculator real quick. 56 minus 27 is 29y equals negative 58. Oh, well, looks like my y is going to be negative 2. So maybe this is going to come out to be something nice and neat. That's negative 2. Take that negative 2, plug it back in. Those of you over here who were graphing, let me go back here. I'm going to take 8x plus 9y equals 6. Move the x. 9y equals negative 8x plus 6. Divide by 9. So y equals negative 8 over 9x plus, I'm going to do 2/3. So you're graphing those two. Must come out. All right, here we go. Y equals. I'm going to have alpha, oops, clear that. Y equals. Alpha y equals. I'm going to do negative 3 on top and 7x minus alpha y equals 5 on top and 7 on bottom. And this one, I'm going to do alpha y equals negative 8 on top, 9 on bottom, and the x, plus alpha y equals 2 on top and 3 on bottom. Negative 2, 1, I bet is where they meet, right there. Oh, nope, negative 2, is it 3, negative 2? Is that where it ends up eating? Let's see. Oh, no, I guess you can't see it. I know the y value said negative 2. Did I punch it in wrong? Let's see. 3 goes into that 2. 3 goes into that 3. Negative 5, 7. Okay, well, let me plug this in. I should get 3x plus 7 times negative 2. I'm going to take this negative 2. I'm going to go back right here and plug it in. Equals, oh, I'm sorry. You know what I did? I just realized the y value is negative 2, not the x value. Because if I graphed it, that's 1, 2, 3. That's like y equals 3. X equals 3, I mean. Let me go back down here. I bet I can find it now. Oh, there it is. 3, negative 2. Boom. Those match, so that means it's at 3, negative 2. I was looking right here at the wrong spot. Over 3, down negative 2. So second table, and there it is. At 3, they're both negative 2. So when I plug that in, I'm just going to go ahead and finish this out. That'll be 3x minus 14 equals 6. 3x, I messed up somewhere already again. 3, oh, negative 5. Oh my gosh. I'm supposed to be copying from this one. Negative 5, is that right? I got to go in too fast. Okay, 3x plus 7 times y. Y is negative 2. Negative 14. So plus 14. I'm going to take that away. Plus 14. Those cancel out. So 3x equals 9. Divide by 3. X equals 3. 3, negative 2. Oh my goodness. Well, either way you did it, whether you graphed it or you did it by elimination, you should have gotten that same answer. Whew, sorry for that, y'all. Thanks for watching.